Okay, so this is Z for 300. What we're being asked to find is I2 using the current divider rule. Remember, whenever we're doing all of these, it's worth labeling your nodes. And with current divider rule, what we're looking for is the node of dividing until the node of rejoining. So the current that's coming into this node is I total. So that would have to be, if we're going to use the current divider rule, we have to solve for I total first. How would we solve for I total? What's our favorite law? Ohm's law. So V equals IZ. I is equal to V over Z. We need our Z total. Z total, I'm just going to start at the top. I'm starting at 20. It goes into here. It's in series with these two in parallel. We have 40J. I guess another step, if you wanted to make sure you don't forget, is to just write all of your J's right here before you get going. Those are positive J's, and this is a negative J because it's a capacitor, right? So 40J is in parallel with 60 minus J30. And then that is in series with J50. Does anyone need me to type this into a calculator? No? Okay, so I'll write it down. I would recommend whatever your calculator is that you go ahead and practice solving for it using your calculator, because we have new calculators, especially with this online form. The total comes out to 97.2 angle 61.8 degrees. That is in ohms, and it is a vector because we're in AC. V 120 angle 0, Z 97.2 angle 61.8, and I total comes out to 1.23 amps angle negative 62 degrees. So now the CDR equation, and I'll put that as a title block. The CDR equation on the formula sheet will, let me make sure I write it as it's written on the formula sheet. So it says IX is equal to I EQ Z EQ over ZX. They're all vectors. And remember, when we say EQ, what we're talking about is everything between the node of dividing to the node of rejoining. Everything from A to C here. A to C, node of dividing, node of rejoining. So whenever I'm saying the IEQ, that is the I total, because that is what is dividing up into there, and what comes out back in 1.23 angle negative 62. But the ZEQ is just this part right here, right there. It doesn't include the J50 and it doesn't include the 20 because that is not in between the node of dividing to the node of rejoining. So I put that as my ZEQ, and then the ZX is the branch that I'm looking at. I'm looking at I2, so everything from A to C inside of that branch is 60 minus J30. You can solve for these piecewise and then plug it into your calculator. I would practice that just to make sure that you are comfortable with these complex numbers in a calculator. But what it finally comes out to is 808 milliamps angle 18.6. So now the next step, question actually real quick, I'm going to pause it. No. Okay, so now we'll do the parts VA and VAC. So if we're solving for VA, that is at this point right here. And remember, a single subscript means relative to the ground. I don't think it was drawn here, but what we'll assume is that it means relative to this point right below the source. That probably should be given if you're being asked to solve for a single subscript, but I know this is what it meant because I could do this. So single subscript means relative to ground. If I'm just thinking about the way that Ohm's law works, I go from ground, I go up to here, and then I go down to VA. So we could just say that VA is simply the voltage source. I'll say voltage source minus the voltage across R20, right? Like I'm doing almost like a shorter part of Kirchhoff's voltage law, that it's risen and then it falls, and I'm just looking at relative to ground. So the voltage source is 120 angle 0, right? It went up that amount. And then this potential difference across R20, I can solve for just using Ohm's law, right? The voltage across R20 is equal to the current going through R20 times the Z of R20. Well, that I of R20 is the IS that we had earlier because it came out of the source and then it kept going through the 20 ohm resistor. And so that's minus 1.23 amps, angle negative 62 degrees. That's the I. The Z is just 20 ohms because it's just a resistor. We don't even have to worry about, if you wanted to say 20 angle 0, that would also be correct. So from there, we get VA 110.6, angle 11.33 degrees, volts. And these are RMS values. Some of the instructors will always write VRMS for their units. I don't usually do that. For me, if I'm solving for VAC, I'll leave it there when we get to it. Personally, I'm going to use the voltage divider rule. And the reason why I do that is because I know, and if I think about this as a circuit, but I'm trying to solve for some voltage away from right next to the source. So you can solve for it in other ways. For me, I see the voltage divider rule the most quickly. So if you solve it another way and get the same answer, then it doesn't mean that you did it wrong. Right, but the voltage divider rule says Vx equals V EQ, Zx over Z EQ. All of these are vectors. And so the total amount, and actually I'll redraw, where should I redraw? I'll redraw it right here, of what I'm doing inside of my circuit is, in order to use the voltage divider rule, everything must be in series. And so if I put all of these Z's in a box, right, that same Z equivalent that we did earlier is what is inside this box from A to C. And so that same 40 parallel with 60 minus J30. I don't think I have, do I? Yeah, 40, there it is, 44.1 angle 54. That's the same as that Z equivalent, right? So there is that Z equivalent, which happens to be AC. It's the same Z equivalent from earlier, but everything must be in series, use voltage divider rule. So what is B dividing up? The pizza's going around the table and it's getting passed to these three guys. So the ZX, I need to know ZAC because I want to know VAC. That is the 44.1 angle 54 degrees. Right, that is ZAC right there.
So that's just the polar form of 60 minus J30, you said?
That's the polar form of 40J paralleled with 60 minus J30. That
Okay,
is
gotcha.
everything that went into between A and C. Whenever I simplified, I did 60 minus J30 paralleled with J40.
Thank you.
Yep. So there's ZAC, and then this happens to be the Z total this time. That doesn't happen every time, but that's what is in series right now. And I'm saying 120 gets divided up between these series elements. So that is the Z total that we had earlier, 97.2, angle 61.8 degrees. And that comes out to VAC is equal to 54.5, angle negative 7.99 degrees. These are vectors.